Hi guys, I thought I'd do a little update here, what's going on. I am waiting for some stuff to come in from AliExpress before I can do some videos on it. But first of all, I've been playing with this, with that, these hot tweezers that I have. Um, as you know from previous videos, they don't work very well, but I was wondering if they could be improved at all, and I think I have. They work half the time now. Before that, it hardly ever worked at all. The reason is this is the original tips that come with them, and they are very long and way too slender, and the heat just can't get to those tips. Also, they're the wrong shape. As you've seen from my other video, uh, proper tweezers, and I've got these now, and these are great. These things, as you've seen from the other video, um, they have shapes like that, and when you squeeze them, they go like that. So I thought to myself, perhaps I can change the shape of these things, and indeed I took the device with them and a hammer, and I have squared them off. First of all, I cut off about that much of the tips, that really the really slender bits, and as you can see, they are a lot chunkier now, and also they got the right sort of shape. They're pointing downwards. They're not these guys, they were just sticking out like that, and that is not the right way. So now you can actually hold components with them. I squared off the tips on them, also, with the hammer on the anvil, so that they have more surface area to transfer heat. And now these things don't have enough power. They're only 22 watts each side, and that's not enough. Um, Professional tweezers like these, they have 100 watts, 50 watts on each side, and also the heat is generated right at the tip here, and which is another thing. I'm waiting for some other soldering irons to come in, and we're going to have a look at soldering irons again as well. But these old-fashioned soldering irons, they had a ceramic insert, and soldering irons are like that as well. The older, cheaper ones, and they just have a metal thing that loosely slips over top of that, so the heat transfer is not that great. And even when you look at older so-called Weller and JBL or whatever they're called, um, soldering irons, um, if you have a ground plane or something, you'll see the temperature going, they'll dip right down. And these modern soldering irons, like these things, they don't have that problem. The heat is generated right here at the tips, so they are much better. Anyway, that's what I've been working on, and it's been successful. I can probably use these tweezers occasionally for some uh, projects that are not so important. Another thing that I'm working and waiting for, I got some new probes. I got this new Regal MSO 5354 oscilloscope, and it came with some probes which I'm less than enamored about. Also, you hear constantly about professionals that the probe should have a higher frequency response than the oscilloscope. The oscilloscope is 350 megahertz, and they give 350 megahertz probes with it, so I don't know what the deal there is, and we're going to investigate that. We're going to check the bandwidth of these probes, so I'm waiting for a few more to come in. These have already come in. These are 500 megahertz probes, and they have the adjustments over here in the actual body of the BNC connector there, which I kind of like. These are 10 times only probes. They don't have a times one, because if you want full bandwidth, you cannot use them at times one anyway. So anyway, we're going to do a thing on probes. Another nice thing about these is that they have um, these things that plug in, so they have a B and C connector on them. You can plug them straight into your signal generators and what have you, so that's another good thing. Another thing that I'm going to be working on is this the garage door openers, which are in my place are about 15 years old. They used to work really well. You would push the button from 100 meters or 100 yards, whatever you want to call it, away, and the door would open. But now I got to walk right up next to the door, and even then sometimes they are hard to open. I'm not quite sure what the deal is there. I have a suspicion that these older garage door openers work on a similar frequency to perhaps Wi-Fi, and everyone's got powerful Wi-Fi routers in the neighborhood, including me, in fact, right above the they're sitting upstairs, right above the garage door opener, and I think maybe that's causing interference. So I bought this little unit over here. Has 4 relays on there and 4 buttons, and I'm going to mount this next to where the buttons are to open the garage doors in the garage, and I'm going to put it right and put some wires from these relays right onto the button inside, so it's like the button is being pushed, and then this control will be able to open them. I've got two of them. Not quite sure what I can do with C and D. Maybe I can hook them up to some lights or something like that. I don't know. In any case, so that's another project coming up. I'm not sure, since that's going to be a rather simple one, and I bought this thing already, complete. So I'm not sure if I'll do a video on that, but that's another thing coming up. And since I'm doing oscilloscope probes, uh, another thing that occurred to me is that, let me push this thing back. Oh, let me move the camera a little bit. I thought I would do some comment on oscilloscopes, how they are connected to ground, and where there could be some problems with that. There's been some other videos on it, but I thought it was interesting to go through some of the equipment I have here to show you where potential problems with that might be. So what I've got done here is I've got a plug over here plugged into the mains, and I've got just the ground in there connected, which is crocodile clips. So in the top right corner you will see that I have, let me move a bit of this equipment away so it's not in the way. Okay, so I am going to connect the mains ground to this probe over here, and in the top right corner you will see the multimeter screen output, and I've got it set to if it makes a connection to ground, you'll see that, and it beeps as well. There's some interesting facts about this. Over here I have a USB, little USB hub connected to the PC, and as you can see, the PC puts ground on the USB ground. It's the mains ground. This here is a PC power supply, and you've probably seen a number of videos where people say take a PC power supply and turn it into a bench power supply, and certainly you can do that, and I have got such a thing here, and I just made out of some scrap metal. In fact, this is part of the old PC case that I I bent, and I made a case for it. This here is the standby output, which I put on a USB port so you can actually charge things on it. But look, you see the ground on this power supply, all the grounds are connected to the earth on the mains. And again, if you look at the oscilloscope, the oscilloscope ground there is connected. And then when it comes to power supplies, I don't know if you can see that one here. Power supplies don't, except that they do have a ground pin on them. See that middle one, and the other power supply that in the corner there, which you can't really see, actually has a little lever that you can connect it to the ground, so you can make the power supply grounded. So, and of course, when it comes to soldering irons, you like these tweezers here, and most soldering irons are connected to ground as well. So the idea, I thought, if you're working on a PC power supply, you really have to make sure that if you're using an oscilloscope or some grounded equipment, normal multimeters are not grounded, so that they are safe. And those little pocket battery operated oscilloscopes, they wouldn't be grounded either. But if you're using a normal oscilloscope, then you might get it in your mind to measure or look at a waveform around an inductor or something like that. And if you then connect the ground lead inside of the circuit instead of just to the ground on the power supply, you could be shorting out the part of the power supply, and that would probably blow up your oscilloscope, especially since these PC power supplies can have hundreds of volts on them. So I thought that was an interesting thing. I went through all the equipment I have and found out which equipment has ground on it. And in fact, I've got some signal generators here, which you can't see. And I've got a frequency counter there. Anything that has a BNC connector on it, in fact, in my lab here, is grounded. So anything with a BNC connecting, a spectrum analyzer, the signal generators, all three of them that I have here. No, this little function generator does not. But the other ones that I have that are bigger bench top ones, they are. So always a good thing to keep in mind to make sure that you don't short circuit anything in the circuitry that you're looking at. And in fact, if you have some circuitry that's connected to you're powering it from the USB port on a PC, it'll also be grounded. So it would be good to use a isolated power supply then as well. So these are just some thoughts. Anyway, as I said, I've got I'm waiting for some equipment to come in. I'm going to do another thing on soldering irons and a video, and I'm going to do a video on these Logic Pros. We're going to test out their bandwidths and see what they're all about, because I bought these guys here on Amazon, and they weren't that expensive, and they claim to be 500 megahertz, and they look good, but we will check them out. All right, so that's all I've got. Just wanted to make sure that everyone knew that I haven't disappeared. I'm just waiting for some stuff, and this is what we'll be doing. So if you like, subscribe, and I'll see you guys later.